So this is the last video in Unit 1 for Algebra 2. We're going to be talking about graphing today, specifically absolute value functions, and then also how to transform those graphs by translating it up, down, left to right, or stretching the graph vertically. So let's go ahead and get started. So there are some parent functions that you may be familiar with already, and if you're not familiar with them, you will be soon. Linear functions, y equals x, that can change to mx plus b, and we can move it around and change the shape of it a little bit. Quadratic functions, those are parabolas. They're in the general form y equals x squared, and that makes a parabola, but it could be moved and shipped around and flipped upside down. Cubic functions, y equals x to the third. Exponential functions, you guys studied those in Algebra 1 briefly. They look like this if it's exponential growth, or this if it's exponential decay. Radical functions, logarithmic functions, inverse functions, sine functions. You may have seen a sine function. It kind of looks like that, but it could be shifted and made taller. But what we're going to talk specifically about today is the absolute value function, y equals the absolute value of x. You did do this function in Algebra 1. But let's go ahead and review, first of all, what the parent function looks like. So we're going to plug in different values for x, like -1, or -2, -1, 0, 1, and 2. And when we do that, if we plug in -2, the absolute value of -2 is 2. And if we complete that whole chart, it looks like this. Then when we plot those points, we have a point here at 0, 0. That's this point. At 0, 0, we have another point at 1, 1, another point at 2, 2, and -1, 1, and -2, 2, and our graph ends up looking like that. So the parent function of an absolute value graph is in the shape of a V. Let's go ahead and then change the parent function to see what happens. So instead of just having y equals the absolute value of x, let's add a 3 to it. What we're going to do then is this. If I plug in a 0, normally I would get the absolute value of 0 is just 0. But now what I'm going to do is I'm going to add 3 to that. So if I take 0 and I add 3 to it, my new y value is 3. And if I do that with the other points, if I plug in a -2, the absolute value of -2 is 2. But if I add 3 to that, I'm at 5. So it takes all of the old y values, which are here, and adds 3 to them and moves them 3 units up. So in other words, instead of a point at 0, 0, now I'm at the point 0, 3. And instead of a point at 1, 1, I'm now at a point 1, 4. And what happens is the entire graph gets shifted up 3 units because I added the 3 at the end. So adding or subtracting after the operation translates the graph up or down. So another example would be if I subtracted 2. It would take all of these old y values, subtract 2 from it, so I would get the new y values, and my graph would be shifted 2 units down because it's a -2. So now that we know how to translate things up and down, now let's add and subtract something before the operation. So before we take the absolute value, let's go ahead and take a function that looks like this. Y equals the absolute value of x minus 3. So we're going to subtract 3 before we take the absolute value. Suppose we want this x to be 0. We want to take the absolute value of 0. Well, I can't plug in 0 for x anymore. What I'm going to have to do is plug in 3. Because 3 minus 3 would give me the 0, and the absolute value of 0 is 0. If I wanted to plug in a 2, let's say, this is actually supposed to be a 4, and this should be a 5 here. If I actually wanted to plug in a 2, then I would plug in a 5. 5 minus 3 is 2. The absolute value of 2 does give me 2. And so I would have my new values of x's. So instead of at a point 0, 0, now I'm at the point 3, 0. Instead of at a point 2, 2, now I'm at the point 5, 2, or -1 or +1, 2, which is right here. And my new graph would look like this. So the new graph is shifted 3 units to the right. If I subtract 3, it's shifted 3 units to the right. Adding or subtracting a number before the operation translates the graph left or right, opposite of what you would think. So if it's minus 3, you'd probably think that it should go to negative 3. But it actually goes to positive 3 because I have to plug in a positive 3 for x to make it equal to 0. Let's take a look at another situation like this. Let's say it's x plus 4. Well, then my new values of x are going to look like this. In order to make it 0, I'd have to plug in negative 4 for x. And so then I would be at the point negative 4, 0 instead of 0, 0. And all of my points are going to be shifted 4 units to the left. So that means that adding and subtracting something before the operation moves things left or right, opposite of what you would think. So now we know how to translate the graph in any direction, up, down, right, or left. Let's try multiplying the function by a number. We call this number a scalar. So instead of y equals the absolute value of x, which is what you see on this, which is what we had before as the parent function, now we're multiplying. After we take the absolute value of it, we're going to be multiplying it by 2. So that means we're going to take these y values. For example, if I plug in a 2, the absolute value of 2 is 2, but now I'm going to take that 2 and multiply it times 2, and that's going to give me a value of 4. And if I do that with all of these numbers, 1 times 2 gives me 2, 0 times 2 is 0, 1 times 2 is 2, and 2 times 2 is 4. All of the points change except the vertex. The vertex stays the same, but the other points are stretched to be twice as tall as they used to be, twice the distance away from the x-axis. So instead of the point 1, 1, now I'm at the point 1, 2. And instead of the point 2, 2, I'm now at the point 2, 4. So it's stretched twice as tall away from the x-axis. So let's try multiplying by a scalar that is different than 2. Let's try 3 times x. So again, I plug in my negative 2, negative 1, 0, 1, and 2, and I get these values. But this time, instead of multiplying those values by 2, I'm going to multiply them by 3. So I get something that's 3 times as tall. And so what would happen if I multiplied everything by a different number that's smaller than 1? We know that when multiplying by a scalar that's bigger than 1, it gets stretched, but it can also get what I'm calling squeezed if I multiply by 1/2 times x. Here I would take all of these values, I would take the absolute value of them and get these values for y, but then I'm going to take all those y values and multiply them times 1/2. So the 2 becomes a 1, the 1 becomes 1/2, and what I get is a graph that looks like this. It gets squeezed, it gets flattened, and closer to the x-axis. So when multiplying by a number, or what's called a scalar, the graph gets stretched or squeezed, or it could get flipped over the x-axis. Let me show you what this would look like. Instead of multiplying by a positive value, a positive scalar, we can multiply by a negative number. So I take all of the x values, take the absolute value of them. When I plug them into the function, I would get all of these numbers here, but then I would multiply all those numbers by negative 2. So I'd have all of these new y values, which would be negative. And when I graph those negative values, like the point 2, negative 4, I'm going to be down here. And all of those points would look like that. It actually gets flipped over the x-axis, reflected over the x-axis. So now we can translate the graph in any direction, as well as stretch, squeeze, or reflect it over the x-axis. The question is, can we do all of this at the same time? So we started with this function and the graph is there. What I'd like to do next is translate this or transform that parent function with the following stipulations. It's now negative absolute value of x minus 2 plus 3. Let's talk and see if we can figure this one out together. So first of all, the negative here reflects the graph over the x-axis. So it would look like this. But then we have the negative 2. Well, the negative 2 is happening before we take the absolute value. That means it's going to reflect, or it's going to translate it left and right. So this is going to move it 2 units to the right because it's opposite of what you would think. And now we're at the blue graph. Well, then we have the positive 3. The positive 3 happens after we take the absolute value. That means it's going to go up and down, and because it's positive 3, we're going to move the graph 3 units up. So I'm going to take the blue graph and move it 3 units up, and I get this solid orange graph that looks like this. The vertex is at the point 2, 3. It opens down. It's not stretched really in any way. It's just reflected over the x-axis before I translate it. So now it's your turn. I'd like for you to take this graph right now and see if you can graph it on your own. Pause the video and see if this is something that you can do on your own. Hopefully you've been able to do that. Let me show you what this graph would look like. The 2 makes it twice as tall. The x plus 1 moves it 1 unit to the right, so the vertex would be here. One unit to the left, so the vertex would be here. And then the minus 4 moves it down 4 units. So the vertex is here, and it's twice as tall. So instead of going over 1 and up 1, I'm going over 1 and up 2. And you can see how that V gets the way that it does because of those different transformations. Let me challenge you with one more thing. Even though you don't know what this parent function looks like, you will by the end of the school year. Can you alter the function so that it is shifted 5 units to the left, it's shifted 2 units down, it's stretched by a factor of 3, and it's reflected over the x-axis? I'm going to give you some time to think about that, see if you can write that down in your notes before I tell you what the answer is. Hopefully you've had a chance to do that. Let me just show you how I would change this. Right now we have the cube root of x. Well, to shift this 5 units to the left, I'm going to have to take x plus 5 before I take the square root. So I'm going to put the plus 5 inside the cube root sign. Now I could put parentheses in here. I don't really need them because I'm going to have to add 5 before I take the cube root anyway. If I want to shift it 2 units down, that means at the very end I'm going to subtract 2 from it. If I want to stretch it by a factor of 3, that means after I take the cube root, I'm going to multiply everything by 3. So it's going to be multiplied by a factor of 3. And then because I want it reflected over the x-axis, I'm going to have to make that 3 a negative 3 so that everything gets reflected. This would be my new function. It would take this graph, whatever it looks like, and it would move it 5 units to the left. It would move it 2 units down. It would stretch it by a factor of 3, and it would flip it over the x-axis. So hopefully that all made sense. There is a homework assignment for today in Math Excel that you can go to, and we will go over questions that you have on this tomorrow.